Electronegativity. Electronegativity is defined as the relative tendency of an atom to attract the bonding electrons closer to itself in a chemical bond. The atom with stronger attraction for the bonding electrons is said to be more electronegative. In hydrogen molecules, both atoms have the same electronegativity. While in HCl molecule, chlorine is more electronegative, therefore the chlorine atom will attract the bonding electrons stronger toward itself. Now we look at the trend in electronegativity across the period and down the group. Across the period, as the proton number increases, the effective nuclear charge also increases. The atoms will get smaller in size, where the nucleus has a greater ability to attract the bonding electrons, therefore the electronegativity increases. As for down the group, as the number of shells filled by electrons increases, the atoms will get bigger in size. The nucleus has a weaker ability to attract the bonding electrons, therefore, the electronegativity decreases. So in here, we can see that fluorine is the most electronegative element in the periodic table. Now we continue with acid-base character of oxides of period 3 elements. When elements react with oxygen, oxides are formed. There are 3 types of oxides. The first one is acidic oxides, and then we have basic oxides and also amphoteric oxides. The acidic oxides react with water to produce an acidic solution, and it also reacts with base to produce salt and water. For example, we have silicon dioxide or SiO2 or tetraphosphorus dicoxide P4O10. As for the basic oxides, it reacts with acid to produce salt and water. For example, we have sodium oxide and magnesium oxide. And as for the amphoteric oxides, it reacts with both acid and base, and we have aluminium oxide as amphoteric oxide. Basic oxides react with water to produce the basic solutions. Here are the equations when the sodium oxide and magnesium oxide react with water. Magnesium oxide is more soluble in acid. It reacts with acid to produce salt and water. For the amphoteric oxides, aluminium oxide is insoluble in water, but it is an amphoteric oxide because it can react with an acid or base to form salt and water. For acidic oxides, the oxides of nonmetals are acidic because they react with water to produce acidic solutions. Silicon dioxide is insoluble in water. It reacts with base to produce salt and water. In conclusion, across the period, as the proton number increases, the effective nuclear charge also increases. The atomic size or atomic radius decreases, ionization energy increases, and the electronegativity increases. As for down the group, as the number of shells filled by electrons increases, the shielding effect also increases, the atomic size or atomic radius increases, the ionization energy decreases, electronegativity also decreases.